Hello everyone, now am I audible? Just audio video. Please confirm audio and video so that we can start the session. Yes guys. So GATE 25, computer science forenoon session completed, and we have received some questions, memory based questions from our classroom students. So I am going to solve some questions here. Those who are live, you can reply in the chat box and please confirm audio and video. So student, as I already informed you earlier, how many questions are MCQ, NAT and all. So total 33 questions MCQ, NAT questions are 14 and MSQ questions are 18. I already made a short video on the same. So these are the pattern of questions that has been asked in GATE 25 Computer Science Forenoon. Today is 1st of Feb. Now guys, here we'll solve the first question that is coming from digital logic. Okay, so basic question, that is question from the number system, and this is a MSQ question. It is a MSQ question. Okay, and the question is 2's complement representation of I am writing in short form, representation of -6 will be, and we have 4 options as well. Okay, we have 4 options. We don't have the exact option data. If you have the option data, you can write in chat box. Right now we don't have the option data, but because the question is very easy, -6 2's complement we need to represent. So guys, it is a very basic concept. If you studied this subject, digital logic number system, then this is a gift for each and every student. I hope every student able to solve this question. It is a very easy question actually, and whatever information we got till now, where 2 options are from 8-bit and 2 options are for 16-bit. Okay. So if I talk about -6, 2's complement representation of -6 will be. So first of all, what is the process to represent a negative number in the 2's complement? So 3 steps we need to follow. First of all, we should write the positive number. So first of all, I need to write +6. The step number 1, if I will write step number 1, so write positive number. So if you will write guys, positive number, can you please tell me how can you write +6? How can you write +6? So you can write +6 as a 0, 1, 1, 0. Tell me guys, yes or no? Now step number 2, because we are looking for the 2's complement, so take its 1's complement. So you can write here take 1's complement. However, these steps are not required in the GATE exam right now, because for the detailed explanation I am explaining like this. Otherwise, in the GATE exam, simply we can, in 20 seconds we can solve. 1's complement, when you will take 1's complement, you will get 1 0 0 1, and finally because of the 2's complement, we need to add +1 to the LSB. LSB is least significant bit. Here we need to add +1. So 1 + 1 0 power mein 1. Here is 1, then 0, then 1. So 1 0 1 0. So it means guys, in the 2's complement, we know that the beauty of 2's complement representation, if you want to increase the representation, if you want to represent the same number in 8-bit or 16-bit, you just need to copy the MSB. It means because the MSB is 1, it is a negative number. So I can make infinite number of ones here to increase the number of bit. Okay. So it means examiner has given 16-bit and 8-bit. So maybe in some of the option you have these 4 1, then again 4 1, then again 4 1. Total 12 1, and after that 1 0 1 0. So maybe one option is this correct, and one representation is 8 representation. It means 1 1 1 1, again 1 1 1 1, total 8, and again 1 0 0 1 0 1 0 1 0 1 0. Okay, we don't know exactly in which option these expressions are there, but whatever information we received till now from the student has replied that 2 options are 16-bit and 2 options are having 8-bit representation of -2 in 2's complement. So that is why wherever these two options are only correct. Again I am telling you, maybe it is in A, maybe it is in C, whatever ABCD sequence, that is not clear, it is a memory based. So I am telling ki wherever this data is there, or wherever this data is there, in whichever option, that options are correct only. Is this clear? So this is a very easy question. I hope you guys completed this, and I hope you guys attempted this if you attempt the GATE exam. Now guys, one more question, easy question, that is from counter. One more question, question number 2 from the subject digital logic only. So from the digital logic, question number 2 says that mode number of the following circuit is mode number of the following circuit is, okay, and the diagram is given to you. This is the diagram given to you. So 4 boxes given to us, guys. Four boxes given to us, okay. So here Q0, Q1, Q2, Q3, like this, all are connected, and here Q3 bar. So this is a circuit diagram given in the exam, clock pulse. So of course it is a synchronous counter. Same clock pulse has been applied to all the flip-flops. Yeah. So here is Q0 bar, here is Q1 bar, Q2 bar. So now student, the diagram is like this. This Q3 bar, this Q3 bar is actually connecting to here D0. So this is a circuit. Now tell me guys, is it a standard circuit of Johnson counter? Have you heard the name of Johnson counter, guys? So if you will directly connect this Q3 to this input D0, then definitely it will be a ring counter, but right now it behaves as a Johnson counter. I hope this is crystal clear. So because of Johnson counter, this is my flip-flop. So how in the Johnson counter, how many states? If we have n flip-flop, for the n flip-flop, we have total 2n states. 2n states. It means total mode is 2n. For n number of flip-flop, total mode is 2n. And the number of finite state is nothing but the modulus of the counter, asking nothing but the mode number, asking nothing but the mode. It means how many number of flip-flop we have, n equal to 4 number of flip-flop. So what is the mode number, guys? The mode number is nothing but twice into 4, that is nothing but 8. So the final answer for this question is 8. Now maybe it is a MCQ or NET, that we don't know, but you can just confirm this data, guys. Can you please confirm this? Can you please confirm this data, guys? Bolo. I hope this is crystal clear. Now, I am going for the next question. One more question is here. That is MCQ. The minimized function of FABCD is equal to sigma of m 0 to 4 8 10 8 10 11 and 12 is. Then some options are there. Okay, so this is the question, guys. How to simplify this? How to solve this? So definitely first of all we have to make a K-map. So just to explain you in a proper way, I am making this complete diagram first. Of course in the examination hall you can make it freehand diagram. So 4 variable K-map we need to make. Now tell me guys here, We have the variables A, B, C, D. A, B, C, D. So here we have 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. Now tell me guys, what is it? 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, 13, 14, 15. Now tell me how many numbers are given to us, how many min terms are given to us. 0, this is 2, this is 4, 0, 2, 4, 8, 0, 2, 4, 8, 10, 0, 2, 4, 8, 10, 11, and 12, 10, 11, and 12. Yeah. So now student, you just need to make a grouping. We are looking for the minimized expression. So if you will go for the minimized expression, tell me. Tell me guys, what is here? So don't you think it is A bar, B bar, A bar, B, A, B, and A, B bar. Similarly here C bar, D bar, C bar, D, C, D, and C, D bar. So the first group, 4 variable group, you will get as a C bar, D bar, C bar, D bar plus. Tell me guys now next, can I make a 4 variable group also, 4 corners also? Yes sir, 4 corners also possible sir. So if I will make the 4 corners, then I will get what? Tell me guys, is this B bar and D bar? Yes sir, B bar and plus B bar, D bar. B bar, D bar, yes. And the last is this only, first only this variable, 2 variable. So the plus answer is A, B bar, C. A, B bar, C. I hope till now everything is clear. I hope till now everything is clear. चलिए बच्चों. So just let me know, am I audible or not?
Hello everyone. Am I audible? Yes. So guys, I'm having few questions. All right. So I'm having 2-3 questions of the engineering maths and general aptitude. Let's see how we can solve. The questions are very easy. Okay. Although we discuss these type of questions in our classroom itself, so very easily we can solve the questions. Let's go with the very first question, which we can consider as a very basic question of the dice. Okay, in the probability, when we discuss lots of the things in our classroom, so we used to discuss these type of questions as well. So here I am having very simple question. I will say one of the easiest question from the probability they ask. You can consider, means it was in the general aptitude, and you can solve it very easily. So a fair dice is rolled. The question is, a fair dice is rolled how many times? 3 times. A fair dice is rolled 3 times. Find the probability of getting, find the probability of getting 6 exactly one time. Find out the probability of getting 6 exactly one time. Let's see how we can solve getting 6 exactly one time. Okay. So I think this was a MCQ and the options available here. Some options are there, so very easily we can solve. So first of all, if I'm solving, I can solve this question using any of the method. Both the methods are very easy. If you can see here, it's talking about 3 dice, okay, means or rolling a dice 3 times. The thing is same to same. So how we can solve it very easily, we can see first of all, it's talking about, if I'm going with the easiest method, so I can see I'm having the 3 rolls. So possible cases are 3 time rolling you need to do. When you are rolling one dice one time, the total number of outcomes 6. When you are going with the 3 time, again 6 power 3, you can use that one. Or if you will go here with the fair dice is rolled 3 times, you are looking for the 6. So probability of getting 6 will be 1 by 6 because this is a fair dice. Probability of not getting 6 will be 1 minus 1 by 6, which is 5 by 6. Alright. My question is talking about ki among these three rolled, I want exactly one time head. So exactly one time head we want. We can go, suppose first time I am getting head itself. Okay. Second time I should not get head. Sorry, this is 6. So first time I am getting 6. Second time I am not getting 6. Okay. And in the third time also I should not get 6. If you are going with this one, now this is possible. It's not that ki first time we are getting 6, second time we are not getting, third time we are not getting. It is possible ki in the second roll you will get 6 or in the third roll you will get 6. So directly we can multiply here with the 3 because for these 1 2 3 rolls we can have 3 different cases. If you want to go with here this one, so this we can solve it. This is 3 times, so this is 25 by 36 into 3, 72. If you are having answer as an MCQ, so this will be the answer. If you want to make one by one the cases, so you can go with one by one case. 6 is possible. Suppose you are getting 6 in the very first roll. Okay, so 6 not getting in the second or not getting in the third one, or it is possible 6 getting in the 6 not getting in the first one, 6 getting in the second one, or not getting in the third one, or again it is possible 6 getting in the first, not in the first one, not in the second one, or getting in the third one. So we can get 6 in the first roll, we can get 6 in the second roll, we can get 6 in the third roll. This is also possible. If you are solving it, this is 1 by 6 for getting 6, not getting 6 is 5 by 6. Okay, the same thing, or will be plus, you can approach it again 5 by 6, 1 by 6 or 5 by 6, or plus again this is 5 by 6, 5 by 6 or 1 by 6. When we will solve, this will be 25 upon 6 into 6 into 6, 216 here. Okay, plus here or plus here. So you can solve the same thing 25, 25, 25. I can solve directly here. This is 216 or this is 75. I can cancel out and I can get the result again 25 by 72. So answer will be same to same for this specific thing. Okay. So let's solve the next question. So this was the first question. Let's talk about the second one, what we are having here. Yes. So this is the first one. Yes, guys. I think I'm live now. Yes, live. Okay, okay. So actually, maybe my connection lost, so I was not getting. Yeah, very good. Rohit, this is same. Mayank, yeah, exactly. 25 by that the same thing. And when I will go with the next one, so one more question I'm having, which is again the easier one. And okay, let's talk about the. Okay, let's talk about the next question, which is from the eigenvalue. The easiest questions of the eigenvalue we are having here, the very basic question, and earlier this type of question already has been asked in the GATE exam. Okay, earlier it has been asked. So the same pattern. That's why I used to tell you, bacho, for those students, now you are having exam today or tomorrow or the next one. So you need to take care of this point ki the question repeats, the pattern repeats from the PYQ, and here we are having the proof. One question I am having the very easy question from the eigenvalue. This is the question of engineering maths. Okay, and this you can consider as a general aptitude. The previous question we can consider as a general aptitude. This question is of the engineering maths, which is of eigenvalue. What? Okay, they are talking about if the matrix A equals to how it's mentioned the matrix as an 1 1 1 or minus 1. Okay, then find out the eigenvalues. Find the short question which we were expecting, eigenvalues of a power 13. Very easily we can solve it, guys. Yes, so Anurag is saying कि next question कराओ. Yeah, I'm going with the next only. कल है maths, कल है paper. Okay, please maths आप पूरा करा दो. तो I'm doing the task only if I'm having the question. If you guys are having question, you can solve it. Whatever I'm having right now, I'm solving the question. So very easy question. We can solve this question using the basic approach. A equals to 1 1 1 minus 1. We can go with sum of the eigenvalues. We know very well in the eigenvalue we should go with the two approaches, sum and the product of eigenvalue. But I am going with the sum of eigenvalues. So sum of eigenvalues is nothing but trace, sum of the principal diagonal. So which is 1 minus 1 0. Second, I will go with the product of eigenvalues. You can use the characteristic equation, but I will not suggest. We can solve it directly, and within the few seconds we can solve it. I'm sure my students solve this question very easily. Product of eigenvalues is nothing but determinate. So minus 1, which is minus 2. Now from the universe, I need to identify, I need to find out those two values, because this is a 2 cross 2 matrix, so two eigenvalues will be there. So from the universe, I need to find out those two values. When you are adding those, the result should be 0 and product will be minus 2. So result is 0, product is minus 2, that is very much clear, plus root 2 and minus root 2. So directly we can write down the eigenvalues of the matrix A will be plus minus root 2. But my question is not asking about the eigenvalues of A. My question is asking about eigenvalues of A power 13. So A power 13 will be, in the GATE exam they asked the question A power 20 earlier. This is A power 13, right? So this will be plus minus root 2 power 13. So plus minus root 2 power 13, it means 2 power 6 I can write down, right? So 2 power 6, when you will go, this is 64, or then you are having plus minus root 2. So directly you can write down plus minus 64 root 2 should be your answer. If you guys were there, you can confirm. Yeah, Mayank, you can confirm 2 root 2 and minus root 2. I don't think so. No. The result will be plus minus 64 root 2, because it's asking about a power 13. Okay, so this is the second question which I am having. If the datas are like this, then this will be surely the answer. Okay, and one more question I am having for the engineering maths. Again, the easiest question from the calculus. Okay, so we can go with that question. This is the question of engineering maths again, with the data. It's given to you function fx equals to ax plus b when your x is less than 1, and for x greater than equals to 1, the value of the function is x cube plus x square plus 1. Okay, this was the question. Yes, this was the question. And what they are asking, they are talking about if f is differentiable, this given function is differentiable everywhere. If this function is differentiable everywhere, it means its differentiation is exist. Okay, left hand derivative equals to right hand derivative you can take, or directly the differentiation is exist. So differentiable, then the value of b. They are asking about the value of b. So first of all, this is the question where you can see the concept of differentiability, but without continuity I am not able to solve. Okay, we know very well if any function is differentiable, then that function is automatically continuable. Okay, because I can see the function is polynomial, the polynomial is continuous and differentiable everywhere. So the function is continuous and differentiable as well. So now if my function is continuous, if the function is continuous बच्चों, ठीक है, if you are writing directly the condition of continuity कि left hand limit equals to function equals to right hand limit. Why? Because my function is continuous. My function is continuous. fx is continuous. ठीक है? If your fx is continuous, it means left hand limit equals to right hand limit equals to function. You can take any one of them even. So when I am talking about this one, so I can take this is a left hand limit now. So when I am writing the left hand limit, which is ax plus b, and we can put it equals to the function. Function, what is the value of function? This is the function. Function is x cube plus x square plus 1. This is my function basically. Okay. So rather than writing this one, I can write down this is my function. If I am putting here x is equals to 1, so this is basically a plus b. This is the function. And here when I am putting x is equals to 1, so this is 1 plus 1 plus 1, which is 3. So we can use it like this, ki left hand limit equals to function, where I am using left hand limit is a plus b now after putting the value of a, and that is equals to 3. This we got as in first equation. Now we can use here, very good, shabash, who's that? Rohit, yeah, exactly. So we can go with the second one as well. What is the condition of differentiability? What is the condition of differentiability? If the function, you are saying the function is differentiable, so let's find out the differentiation or the derivative of the function. Derivative will be a plus b for what? X less than 1, and for this one will be 3x square plus 2x for your x is greater than equals to 1. Okay? If your function is differentiable everywhere, then these two things must be equal. Right? Achha, I am going for the differentiation. Now, so ax will be a only. Directly we can write down a. There is no requirement of writing b because differentiation of b is 0. So if the function is differentiable, then these two things must be equal. So when you are putting these two things equal, so this is a equals to 3 at the place of x. I can put now 1. So 3 into 1 plus 2 into 1, which is giving me the result a equals to 5. My question is not asking the value of a. My question is asking the value of b. So we can put here the value of a, which is 5. So 5 plus b equals to 3. You are getting b equals to minus 2. Khatam. Very easily we can solve this question. Alright? Yes. Shabash. So the easiest question, very simply we can solve it and we can get the result. If I am talking about the next question, So one more question I'm having, but I'm not sure about the datas, or even I'm not sure about the options, but I'm writing if the student is talking about ki this is the question. So if this is the question, one more question of this is talking about ki given the function fx equals to cx square when your x is existing between 1 to 4, then it's asking about, and otherwise it is 0, otherwise the value of function is 0. So then it's asking about find the value of probability when it is existing between 2 to 4. If you guys were there in the exam, so you can confirm whether this was the question or not. Whether this was the question or not, bacho. If yes, then only I will proceed. If no, then I will not go. Very good. We get the result. What is for this one? You are getting the result. Moyank, is this the question? The question was there. The question was there. First of all, please confirm. Let's see. Okay, according to my data, if this is the question, then how we can solve it? We can solve it first of all because here C is unknown quantity, and had they given the value of the C, I don't think the value of C is not given. So first of all, we need to find out the value of C using the integration minus infinity to infinity. So first of all, I need to find out the value of C using this integration minus infinity to infinity fx dx equals to 1. When I'm going with this one, so because I can see my function is exist between 1 to 4 only. My function is exist between 1 to 4, okay, and 1 to 4. When I'm going with this one, this is cx square dx equals to 1. Okay, so 1 to 4 only. This is cx cube by 3. The result is 1 to 4 equals to 1. When we are putting c by 3, we can take outside. 4 cube is 64 minus 1 equals to 1. So 63c by 3 equals to 1. I am getting the value of c as in 3 by 63. Isn't it? The value of C. What you are saying? It's asking about 2 to 3. Pratham, they are asking about the result 2 to 3. It's not 2 to 4. Is it 2 to 3 only? You guys can confirm. And the value of this C will be, because when I'm solving this is 4. Yeah, Rohit, the final answer you are talking about. Let's see. Let's see. ठीक है, तो I'm solving the data which I'm having. According to that one I'm solving. If you guys are having some correction, so you can tell me. Otherwise I'm solving according to the data which I'm having. So this will be C. I'm solving it. Okay, x cube 1 by 3 we can take outside. The range is 1 to 4. So this is 4 cube. So 4 into 4 into 4. Okay, 64 minus 1 we can take. So 63 by 3. So C is 3 by 63 I'm getting here. Now I need to solve this result 2 to 4. When I'm solving it for 2 to 4, so because now I can find out the integration a to b fx dx is the probability. This is the continuous random variable now. So probability density function is this one only. So when you are solving, when you are using here the limit 2 to 4, okay, which I am having according to that one 2 to 4 only. ठीक है, Abhishek is saying ma'am this is 2 to 4 only. So ठीक है, we are solving for 2 to 4. So when this is 2 to 4, this is c x square dx, okay, and 2 to 4 is there. C again, I should write down. C is there outside. I will write down it. The integration x cube by 3. Result is 2 to 4. Okay, this is my probability. So I can write down the result of C as in 3 by 63. C will be 3 by 63, and this I am having again the x square only itself. So this will be 1 by 3 is outside. This is 4 cube, okay, or minus 2 cube. When you are solving, 3 and 3 will be gone. Okay, correct. 3 and 3 will be gone. Okay, so the result will be, we can solve it in the decimal. If this is in the decimal, so it should be 56 by 60, is it in the decimal? I'm writing it 56 by 63 or 0.88. ठीक है, any one of them should be the answer. Any one of them should be the answer. If the options were available, then this is 56 by 63. If options not available, okay, if this is an NAT, then it is 0.88. So if this is the question, this type of question also has been asked in the GATE exam. Again, I'm saying, bachcho, for those students who are having exam the next tomorrow or in the on the 15 and 16, please take care of this thing ki PYQ pattern repeats. And this is the proof. In this paper, only 2 questions, 2 patterns, same to same pattern repeat. This one and the previous one. Which one? This, not this one. This pattern. Okay. So we can see the pattern repeats itself. So that's it from my side for the maths. Till now I'm having these questions of maths and aptitude. If you guys are having, you can share the questions in our Telegram group. Okay, so once you will share the question, then we will confirm the data and then we can solve the questions for you. Okay, so this is from my side. Now just stay connected here for the more technical subjects. Stay connected here only. So okay, just here only, guys. Wait. Yes, Pankaj, it is 56 by 63. Correct. Absolutely correct.
Hello everyone, how are you? I hope your preparation is going well and you have done very really and good in the examinations. Am I audible to everyone? Please confirm. Please confirm. Am I audible? Hello. Very good. Okay, now let's see. First, start discussion some this marks distributions per subjects. Okay. So if you see, as we discussed in the classroom also, so in the DBMS they asked 8 marks. Okay, 8 marks in the DBMS, and if you combinedly see this data structure and algorithm C programming, they asked 17 marks. Okay. Very important this two subjects, and mostly the mark distributions are as per discussion we have in the classrooms. Okay, fine. So let's see first the questions. Start the questions first. Questions. Okay, see, let us start the first question. First question from the operating system. Okay, this was of an MCQ 2 marks question. Fine. In these questions we are given a system. Okay, system with 2 processor, M1 and M2. Fine. And in the systems we are given with four processes. We are given with the P1 processes. Here is P2, P3 and the P4, and their burst times. Their burst times are also given here. The P1 burst time is 20, P2 burst time is 16, this is 25, and the P4 burst time is 10. Okay, these are the burst time of these processes, and here this system is using using non-preemptive, okay, priority scheduling, fine, okay. And now the priority here, the priority are assigned as, for this processor M1, okay, the priority is assigned as here, this P1 is having highest priority than the P3 and greater than P2, greater than P4, like this. This is a priority of this processor P1. Getting my point now? Processor P1. And now here this P1 is having highest priority and this P4 is having lowest priority. Fine. Now if I talk about the machine M2 or the processor M2, the priorities are P2 greater than P3, greater than P4 and P1. P4 and the P1. Fine. And options here, options are given with, one option was 7.5 millisecond, second was 9, and here the third okay, the third option was 6.50 and fourth option was 8.75. What was the answer? What was the answer for this question? Anyone? Okay, hello everyone. Am I audible? Please confirm once. Am I audible? There are some technical issues. Can you please confirm? Am I audible to everyone? Okay, so I was discussing these questions in the example. This question was given in the MCQ 2 marks OS. Fine. We are given with a system, okay, two process systems M1 and M2, and we are given with the 4 processes P1, P2, P3, P4 having the burst time 20, 16, 25 and 10, and the system is using the non-preemptive priority scheduling. Fine. So M1 priority is having P1 greater than P3, then greater than P2 and greater than P4, like here. Fine. And M2 is having same priority here. Okay. And options are given in the millisecond. Asking the question was find the average waiting time. Find the average waiting time. Okay. Fine. So anyone answer these questions? Have you attempted these questions in the examinations? Please confirm the answer, solution. Anyone? Okay. Let's discuss. Fine. Okay. Now see here. So we are given with 2 processor system. Fine. A system with 2 processor. So let's draw the Gantt chart. Okay. Gantt chart for the 2 processor. Gantt chart for the 2 processor. Fine. We are having this 2 processor. Okay. Now here see, this is our processor M1, this is our processor M1, this is our processor M2, fine. Getting my point now? Understood? Now see here, now initially all this processor M1 and M2 are empty, means they are initially don't have any process to start with. So see here, now in the system we are having 4 processes and all the arrival time of all the processes are 0. Fine. Arrival time is 0 only, means all the processes are available in the system at time 0 only. Fine. Now see here, so now on this machine M1, okay, on this machine M1, or if you check the priority of this M1 and M2, okay, list having priority M1 and M2, then I can say here this P1 is having highest priority, then P3, then P2 and the P4. Understood? Similarly here, on this M2, we are having this P2 is having highest priority, then P3, then P4, then P1. Fine. So see here, initially the M1 was empty. Fine. So what we'll do, first we'll start with this P1 here, first on this P1, on this M1. Fine. So we'll start with the P1. Fine. And the P1 burst time is 20 only. Getting my point here? So P1 will start with time 0 and it will continue till time 20 here, because the system is the non-preemptive scheduling algorithm, so it will continue till 20. Understood? Now see, at time 0, M1 is having this P1 processor and M2 is empty here. So what will happen? So now on this M2 also we'll schedule one processor as per this priority here. So on M2, see here, P2 is having highest priority than remaining else here. Fine. So now in the system, P1 is already executing on the processor M1 here. Now remaining left with the P2, P3 and P4. Now in the P2, P3 and P4, on machine M2, P2 is having highest priority. So what will happen? On machine M2 will continue with the P2 here. P2, fine. Getting my point now? And P2 burst time is here 16. Means here it will continue from, we can say here, this P2 will continue from 0 to 16. Fine. It will continue from 0 to 16 on the machine M2. Okay, processor M2. Getting my point now? Now see here, now see. Now here see. So at time 16, now processor M2 is done with the P2. Now it is having, means if you are having any other process, we can simply assign it here after this 16 here. Now see here, now at time 16, M1 is busy with the P1 and M2 is ideal here. Now what will happen in the system? In the system, I will left with this P3 and P4. So now on the M2, we are having the priority and P2 is done here, P2 is done here. Now left with the P3, P4 here. Getting my point? So in the P3 and P4, P3 is having highest priority on the M2. So what will happen? We'll assign this P3 first here. Okay, here P3 will be assigned. Getting my point? And the P3 burst time is 25. So it will start with after 16 and it will continue. 16 plus 25 is, okay, 11 and then 1 it is 4, 41. Okay, it will continue till 41 here. Getting my point now? Now see, in between here at time 20, M1 completed with this P1. P1 is completed, fine. P1 is completed here and P2 is also completed. Now, so after this time 20, M1 will be ideal. So what will happen here? We'll assign if they are having any processor in the system. Now see here, among this P3 and P4, P3 already scheduled on the processor M2. Now we're left with the P4 only. So what we'll do? We'll simply schedule this P4 on the processor M1. So P4 will be scheduled here. Understood? So it will complete at time 30 here. Getting my point? So on processor M1, P1 and P4 are completing, and on processor M2, P2 and P3 are completing. Getting my point now? Done. So what will happen? At the end, we'll just find the average waiting time. So see here, how to find this average waiting time? Simply write the completions time. First find the TAT. So if you see here, we are having the 4 processes, P1, P2, P3 and P4. Getting my point? And completions time of these processes are, completion time of P1 is nothing but 20. At time 20, P1 is completing. Similarly, what is the completion time of P2? P2 is 16 only. Here it is 16. Fine. Now here see. So here M2, P3 completion time is 41. This is 41. And P4 completion time is 30. Fine. So what will be the average waiting time? Average here waiting time is nothing but TAT minus, or let's find the TAT also. TAT. What will be the TAT? TAT will be completion time minus arrival time, and all the process having arrival time is 0, so TAT will be nothing but same. 20 minus 0 is 20, 16, 41 and 30. And lastly here just find the waiting time. Here waiting time will be TAT minus the burst time. TAT minus burst time. Now see, the P1 TAT is 20 and P1 burst time is 20 here. So 20 minus 20 will be 0. This waiting time of P1 is 0. Similarly here P2 TAT is 16 and P2 burst time is 16 here. So 16 minus 16 0 only. Fine. Similarly here P3 TAT is 41 and P3 burst time is nothing but 25. So 41 minus 25 will be here nothing but 16 only. Okay. The waiting time of P3 will be 16. Similarly here, what is the waiting time for P4 here? P4 TAT is 30 and P4 burst time is 10 here. So 30 minus 10 is nothing but 20 here. Okay. So these are nothing but the waiting time of the processes. Okay. P1 is having 0, P2 is having 0 only, P3 is having 16 and P4 is 20. Fine. So if you find the average waiting time here, the average waiting time is nothing but here 0 plus 0 plus 0 plus 16 plus 20 divided by 4 only. So if you see here, it's nothing but here 36 by 4, this is 9 millisecond. Understood? So answer is 2 only. Getting my point? Understood? Okay. Now see, let's see one more questions here quickly. This is from the DBMS. Okay, SQL based question here, see. DBMS. Fine. This is of 2 marks questions from the NAT question. Fine. Okay. Let's quickly draw the table. Okay. In this problem, we are given with 4 tables. One was the player table. Okay. Here we are given with the player table. This is a coach table. Coach is having only 2 attributes. And then we are having here is a team. Team is having this 4 attribute. Then last one was the member, only 2 attribute. Fine. This was given with the 4 table. Fine. And data was, see here. So in the player table, we are given with the player ID, player name, fine, and their age. So first player was P1, PID is 1, okay. Name is Jasprit. Age was 31. Second player ID was 2 only. The name was, okay, keep it Rohit only. And here the age is 24. Fine. Similarly here, the third was Isan. Okay, age was 26. And last was his 4, Akshar, and age was 30. Fine. Second was the coach table. Coach table is having this coach ID and the name, coach name. Fine. So we are having 3 coaches. So first coach ID is 101, Ricky. Then 102, this is Mark. And then 103, it's Trevor. Fine. Now the next is our team. This is a team relations with the team ID, then team name, okay, then team CT and their CID, okay, CID, coach ID. Fine. Now see, we are given with here is 3 team. The first team was 10 and the name was MI and the city was Mumbai. Fine. And the coach ID here is 102. Similarly here the second team was 20. The team name is Delhi Captains, we can say, and the city is Delhi. Fine. Similarly here this ID is 101. The third team was 30 and this team was from the Punjab team, and Mohali was the city, and this is 103. Okay, this was the team. Fine. Similarly here the last table is our member. Here this was the PID and the TID. Understood? So here the data was 1 and this is 10. Then this is our 230. Then 310 and 420. This is the complete table, okay, given with the relation. Okay. Now we'll write the SQL. There was one SQL given and the question was find the value that is returned by the SQL. Fine. This is our table. Fine. Let's write the SQL quickly. See here, our SQL here. SQL is our select minimum, okay, minimum p dot as, okay, from player as a p, means this relation p player is renamed as a p. Okay. Now see here we are having where, okay, where p dot id, okay, p dot pid in. Okay, here this is a in operator. We already know this in operator is used for the membership testing. Fine, membership testing. Now quickly see here, this was the in, and write here the nested query. Fine, the query part here. So query is here, we are given with select m dot pid from team T, then coach C and member M. Fine. Then here we are having this where C dot C name, coach name is equal to Mark, okay, and we are given with T dot CID must be equal to C dot CID, and we are given with M dot TID is equal to T dot TID. Okay, this was the complete SQL, and the question was find the value that is returned by this SQL. Fine. So quickly see the SQL here, given SQL. So if you see this properly, then first tell me whether this is a nested, okay, SQL with correlations or without correlation. First see whether this is a with correlations or without correlation. This SQL is without correlation. Getting my point? Because here in the nested SQL, if you see here, the inner query, we are not using any attribute of the inner query, we are not using any attribute of the outer query. Getting my point? So because of this, I can say this is a nested query, this is our inner query. Fine. This is our inner query. We are having this inner query. Inner query is independent of the outer query. Understood? So this is nothing but this SQL is a without correlation. Without correlation. Understood? Getting my point? Fine. So first what we'll do here? First we'll find the result of this inner query, and that result will be used as an input to the outer query. Getting my point? Done. So first find this result of this inner query. So if you see here, so always SQL always start from the from clause here, this from clause. So I can see from clause we are having this team T, coach C and member M. So we'll do the cross product between the team T, coach C and the member N, and then we'll apply the where condition on this result of this from clause. Getting my point? Now see here, so let's assume here, so we did the cross product between the coach, team and the member. Okay, from means where we done the cross product between this three table. Now apply the condition here. So see here, now condition is where C dot C name is equal to marks. Means here. So from this coach table, remove all the records where this coach name is not equal to marks. Okay, or just keep all the records having coach name equal to mark. It means here this 2 record will be removed. Okay, this 2 record will be removed here. This first record, this will be removed, and here this will be removed. Means we are only left with the 1 record having this coach ID is 102 and the name is Mark. Done. Very good. Next here is, so C dot C name is equal to marks. Okay, we got the marks record here, and T dot CID is equal to C dot CID. Means here our T dot CID is here. So team is T here. This is our T, this is our C, and this is our M. Fine. Now see it says here first compare the T dot CID is only this. Okay, and our coach C dot CID is this only. Means if both are equal, and if means retrieve the M dot PID if coach ID is 102 and for the team member is here, team is our this T dot TID. Fine. Getting my point? So see here, this Mark coach, Mark is managing the here, it is a coach ID of 102 and 102 here, this coach this coach ID is 102. This is a coach of this team 10 here. Getting my point? It means here we'll only keep this record. Okay, this 10 MI and Mumbai, remaining all will be deleted here. Understood? And now we'll retrieve this M dot PID if it is matching with this only T dot TID here. Okay, if it is matching with this, we'll retrieve the PID here. So see here, for this Mark is managing the team here 10 only. So how many team is managed by this here? Team ID is 10 only. So there is 2 team here. So first is having PID is having 1 and other is nothing but here 3 only. So inner result will be here. The inner result will be, table result will be here. This will be M dot PID. Okay, this will be M dot PID. It will be 1 and 3. 1 and 3 means we got the inner table result here. Inner table result nothing but here 1 and 3. Getting my point? Now here next step is okay, in the outer relations, take each record here from the player P, take each record and just see here if that player ID is in the list of this here. If this player ID is present or member of this inner query result, then simply select that record here. So see the first record is having player ID is 1. Now check here, is this member of this result here? Yes, means select the first record. Similarly, second here, so second PID is 2 only. Is it member of this set? No. Then reject this record, second record. Similarly, third here, so third is having this 3 Isan and 26. So this 3 is our PID here. So check here, is this PID, period PID, is this in this set here? Yes, yes means select this record. Similarly here, last one is, okay, 4. 4 is not in this set, simply reject this record. Okay, it means, so after this where condition from this outer relations, we got only 2 records. First is our first Jasprit 31 and the second is 3 Isan and 26. Getting my point? Now out of these 2 records, find the minimum, okay, find the minimum age of this record. So let's select from the selected record here. So from selected record, the minimum age is 26. So it will result this 26. Getting my point now? So it will result this 26. 26 is the answer. Understood? Yeah, 26 is the answer. Very good. So here the answer was 26. Very good. Fine. Okay. Now let's see one more questions from this B plus tree DBMS. Okay. DBMS, and this was the MSQ question. MSQ questions of 2 marks. Getting my point? Now here they have in the question it was given that consider the B plus tree. Consider B plus tree with 5 nodes. Okay, with 5 nodes, and a node can have at most, okay, at most 3 keys. Fine. A node can have at most 3 keys. At most 3 keys. Understood? And the structure was given here. See, the structure was given a tree with 5 nodes. This was the root node. Here it was the first child, second child, third child, and fourth child. Fine. And here the data was here in the root nodes here. 3 keys was there. 3 keys was here. This 6, okay, then 12 and 9. Okay, and this pointer is pointing to this node here. This was pointing to the second child, third child, and the last child. Fine. And here actually in the paper it was given, the data was given here. See, this was incorrect. The data was actually given with 1, 4, 3. But actually this B plus tree is nothing but is a BST only, search tree only. So actually this data should be 1, 3 and 4. Getting my point? 1, 3 and 4. So let's just make it correct here. In the paper it was given with 1, 4, 3. So 1, 3 and 4. Similarly here we are also having the same keys here is 7, 9, 10. 7, 9, 10. And here is 13, then 15, then 17, and the last one was, this was, okay, 20, 21 and 22. Getting my point now? Understood? Now the question was, if we insert, okay, if we insert a new key with value 23, if you insert a new key with value 23, okay, this is nothing but our 19. Fine. So here if we insert key 23, then here it was some options was given here. So option, I am writing just option here. So option A was something, okay, so the height of the tree will increase. And the second option was here, okay, the second option was at least one or more, okay, at least one node splitting. I think something like here, node splitting, okay, or C option was no node splitting, and the D option was okay, I'm just forgetting this last option. Some option was given here. Let's keep none of this here. None of this. Tell me, anyone what are these questions? What was the answer? What was the answer for this question? What was the answer? We have already discussed so many questions in the classroom, how to insert a keys into the B plus tree. What is the answer here, Baba? Now, if okay, A and B, very good, yeah, A and B the right answer. See, if you observe one thing here, A and B the right answer, not B and C, A and B the right answer, yeah. So, if you observe one thing here, if you observe one thing properly, then this is not the B plus tree structure, because we know in the B plus tree, either this tree will be following the left biasing or the right biasing. So, what this biasing means? Biasing means, so one of the means the copy of this internal node keys will be copied into the leaf node here. But if you see here, this 6 is not present in the leaf node, 12 is not in the leaf node here. It means basically this given we can consider this is a B tree only. Okay, B tree structure. B tree structure. Getting my point? Understood now? Now see here, in the question it is given already, a node can have maximum at most 3 keys. Okay, if you see here, all the nodes are fully occupied. We don't have any space to insert any more keys here. Fine. It means here, if you insert one more keys with the key value 23, so here the key value is 23. So where it will be inserted here? Then we will compare this 6. So 23 is more than 6. It means this 23 will be the right tree of this 6 here, right subtree of this 6 here. Then we will compare with this 12. Again this 20 is more than 12. Then go to right here. Then again 19 here. Again this 23 is more than 19. Then go to right subtree. Means this 23 will be inserted into the right subtree of this 19 here. Insert 23. Getting my point? Now see this last node here, this last node is, okay, this last node is nothing but fully occupied. Getting my point here? So what we will do here simply, so first what we will do, we will write all these keys in ascending order, okay, whatever we have inserted in here. So if you write here nothing but, this will be 20, 21, 22 and 23. Understood? Now we'll take the, we'll split into the leaf nodes here, and we'll take the root node as a middle element. Getting my point? So middle element is 21 and 22. So we'll take any one, either 21 and 22. So we can keep here, let's keep it here 22 here. Understood? So what will happen? This node, this leaf node will be split into two parts here. So one node structure will be nothing but, it will be nothing but here. It will be, okay. So one node structure will be here. 1, 2 and 3. So one node value is having this 20 and 21, and other nodes here will be having this value 1, 2, 3. It will be having this 23. Getting my point? Now this 22 will be promoted to the root node here. Now see, as soon as we'll insert this or we'll promote this 20 to the root node here, okay, insert this 22, then what will happen? This root node is already fully occupied. Getting my point? Then what will happen? This root node again, because this root node is already fully occupied here. So if you want to insert this 22, then we need to perform the root node splitting here. Understood? So again, same thing here. If you perform the root node splitting here, or we can say the root splitting here, then what will happen here? So keys are nothing but 6, 12, okay, 6, 12, 19 and 22. Again, just find the middle element, anything 19 or 12, just keep this only. So this will becomes the left subtree of this root 19, and this 22 will be the right subtree of this root 19. Getting my point here? It means here, if you perform the root splitting, then height of this tree will be increased. Means now the new height of the tree will be, height of new B tree will be nothing but, it will be nothing but only 2 only. Understood? Because now the height is 1. If you perform the root node splitting, then the height will becomes 2 only. Okay, it means the height of this tree will increase. So A is correct. And here at least one node splitting, yeah, where we are performing the node splitting here, one is the leaf nodes and one is the root node here. So we are performing at least one, means one or more. So again B is also correct. Understood? So answer is A and B. Answer is A and B. Any doubt here? Done na? Answer is A and B. Now let's discuss more questions here. Let's see. Okay. Hashing question. Okay. as we discussed, there is a hashing question. Hashing question, see here, hashing question was, so system is using this double hash, okay, double hash with the first hashing function is given, h of k is nothing but, this is given as our k mod 11, k mod 11, and this hash 2, the secondary hash functions is given as 1 plus k mod 7, 1 plus k mod 7. Getting my point? Understood? And here the hash table size. The hash table size is given here. This hash table size m is given. M is given as our, m is given as here 11. Understood? Getting my point? Now in the question it says here, for the ith probe in open addressing table, the size m is 11 only, fine, open addressing table, the function here, the function is given as here, the function hash function is given as h1 of k plus I into h2 of k, okay, then plus here, not plus here, it will be mod of m, okay, and here the I value is not given. So again, if you are probing this, you can just take this I value, I belongs to 0, 1, 2 like this. Getting my point now? Anyone solve this question? And here the keys are given. The keys are given 63, 50, 25, and here 79, 67, and last is 24. And the question was where this 24 will be inserted, okay, index location, where this key 24 will be inserted. Anyone solve this question? Anyone? Okay. Now see here. Now let's take the table here. This is our hash table. Let's take the hash table. Let's take it here, and it will be having 11 slots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Getting my point? So here this hash table is given with the index is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Understood? Fine. Now see here. Now if we okay, start inserting the keys here. Let's first insert the 63. So first our keys is 63. Okay, 63 here. Then simply pass this 63 here into this hash function here. Getting my point? Now see here. If you pass this 63, then what will happen here? The locations will be nothing but h1 of 63 plus, okay, here this I is because starting with 0, so it will be nothing but here 0 into h2 of k, h2 of 63, and then it will be having mod of 11. Getting my point? So let's find what this value is. H1 of 63 it is mod 11, so it will be nothing but 55, and 55, 5, 63, 8 plus this is 0 and mod of 11, so value will be 8 only. Now see, the location 8 is empty, so insert this 63 at location this 8. दो बार collisions होगा, yeah, absolutely. दो बार collision, fine. Now see here. Now see again this see here. Next is our 50. Key is 50. So find the location. Again h1 of 50. h1 of 50 plus 0 into h2 of 50. Mod of 11. So if you see here, what is this h1 of 50? h1 of 50 nothing but 45, 5. Getting my point? 11, 44, na? 44 plus 66 plus, okay, 0. 6 plus 0, mod of 11 is 6 only. So 6 is empty, so insert here this 50. Okay, getting my point? Insert this locations here, that is 44, 6 plus here is 50. Fine, very good. Now here the third is our 25. So key is 25. Key is 25. So key is 25. Getting my point? Then simply insert it here. What will happen? Location. Location will be h1 of 25 plus 0 into h2 of 25 mod of 11. So what is h1 of 25? Again 11 2 times here 22, 3. 3 plus 0. 3 plus 0 mod 11 is nothing but 3 only. So 3 is empty. So insert this 25 here. Very good. So this is done. 25 is done. Then 79. 79. So insert one more time 79. Key is 79. Then location. Location will be h1 of 79 plus 0 into h2 of 79 mod of 11. So here the value of 79 is nothing but 2 only. Getting my point here? 77 it will be 2 only. The remainder will be 2 here. 2 plus 0. 2 plus 0 mod of 11 is nothing but 2. So empty location is 2 only. So just insert this 79 here. 79 here. Very good. Let me quickly compress this data. Now insert. Let's insert 2 more keys here. So here the fifth one is the key 67. 67. 67 location will be h1 of 67 plus 0 into h2 of 67. Okay, mod of 11. So here again what is h1 of 67? Again 1. So 1 plus 0. 1 plus 0 mod of 11. This value will be only 1. Getting my point? 67 1. So here this is empty. So insert here is 67. Done. So let's insert now this 24 here. 24. Okay. So let's insert here is key only. So key is 24. So again what is location? Location will be h1 of 24 plus 0 into h2 of 24. 24 mod of 11. So I can see 24 h1 of 24 will be nothing but remainder will be 2 only. So this is 2 plus 0 mod of 11 is 2. So if you see here, so already this 2 is already occupied by 79. It means here this is nothing but here collision. This is a collision. Getting my point here? So what we'll do? Again we will take this I to 1. We'll change the second is 1 only. Fine. So now here see. So here now the location will be okay, h1 of 24 plus 1 into h2 of 24, and then lastly it is a mod of 11. It is mod of 11. Mod of 11. So what is h1 of 24? This h1 of 24. This h1 of 24 nothing but 2 only. So 2 plus, okay, 2 plus what is h2 of 24? If you pass this 24 here, so this is nothing but 1 plus 24 mod 7. So 24 mod 7 nothing but here we can say this remainder is 3 only, okay. 24 mod 7 is 3 times, so remainder will be 3. 3 plus 1 is 4. Getting my point here? This is 4 only. So here it is a mod of 11, so it is 6 only. So if you see here already 6 is occupied by here this 50 here. So it means again there is a collision. Here it is a collision. Okay, there is a collision. Then what will happen here? Again we'll perform the same with I equal to 2. I equal to 2. Okay, like here location h1 of 24 plus 2 into h2 of 24, then mod of 11. Getting my point? So what is h1 of 24? This is 2 only. So 2 plus 2 times of h2 of 24 is nothing but here it is a 4. Getting my point? So it will be nothing but 2 plus what is this? 2 into 4 nothing but 8 only. Getting my point? 8. And mod of 11. So nothing but here 8 plus 2 is nothing but 10 only. So 10 mod 11 is 10. Now see, location 10 is empty. So insert this 24 here. 24 is, getting my point? So here the answer this index, okay. For the last key 24, the index will be, the index value here is nothing but here 10. 10 is the answer. Getting my point? Understood? Any doubt? Okay. Any doubt? All clear? Fine. Now let's see here One more question. One more questions from this DBMS. From this DBMS, see here. DBMS. This was this question was of 1 marks. 1 marks. Question was this MCQ. MCQ and from the transaction. From the last chapter transaction. Fine. The question was given as something. Consider this schedule here. Schedule S. Schedule was given as R1X. R1X. This is easy question only. Okay. This was read of X. Okay. Then W1 of Y. Then R2 of X. R2 of X. Then we are having this R2 of Y. Then we are having R3 of Y. R3 of Y. And then here the last one is abort. Abort of T1. Abort of transactions T1. Means the question was given with, we are given with the 3 transaction, getting my point, T1, T2 and T3, and here the R of X nothing but read only, and W of X is nothing but write on the X item, like here given, and this was the given schedule S. Understood? Now the question was here, okay. So if in the schedule we are having this abort of T1, then other means how many other transactions will be rolled back because of this abort of T1, okay. Other transactions need to roll back. Other transactions need to roll back. This was the question, and here the options were given. Options were given. The option A was given with, okay, only T3. B was given with both T2 and T3. C option was given only T2. Only T2, and D was given with neither T2 nor T3. What is the answer? Anyone? Okay. This question is from the cascading rollback topic. Fine. So we have already seen. Let's quickly see here. Let's see. So how many transactions are given here? 3 transactions are given. Fine. So we are given with the 3 transactions. One is our T1 transaction, one is the T2 transactions, one is the T3 transaction. Fine. And the first operations in the T1. The first operation in the T1 is nothing but is a R1 of X. Here we are having this R1 of X. Then we are having this W1 of Y. Then after this we are having this R2 of X. Then we have R2 of Y, and here we are having this R2 of Y, sorry, R3 of Y. R3 of Y. Fine. And here it is a abort T1. Means because of some problem here, we need to abort this T1 because some problem crash or anything. So we need to roll back this T1. Getting my point here? Understood? Now see here. So because of this abort operation on this T1, now if you observe carefully, here, okay, we are having one dirty read. Dirty read is here. This Y data item is, okay, written by the transactions T1, and after this operation, see here. So this T2, okay, this T2 is reading this data items, this T1 or Y data items that is updated by this transaction T1. So here we are having this dirty read. Okay, we are having this dirty read. Similarly here, this transaction T3 is also reading the data item, same here is Y. We are also having this dirty read in the T3 also. Getting my point? Means transaction T2 and T3 both are reading the data item Y that is updated by transactions T1. Understood? Getting my point now? So again, because of this dirty read, so if this T1 is getting rolled back, getting my point? It means all these dirty reads, or we can say that transaction T2 or T3 also gets rolled back here. Understood? To remove this dirty read problem. Understood? So here the transactions T2 and T3 also gets rolled back. So both transactions T2 and T3 will be rolled back. So answer is B only. Answer is B. Understood? Fine. Now let's see what are other questions here. Let's take the programming questions quickly. See here. The first and simple programming question was of the 1 marks question was C programming. Okay, NAT questions, it was NAT of 1 marks. Fine. And question was, okay, it was given with int main int main, okay, and the problem was given with here, there is a integer pointer z, okay, then we are having this int a is equal to 20, b equal to 25, getting my point. Then we are having here z equal to n% of this a, n% of this a. Then we are having this foo of z comma b. We call this function foo. We will see this function also. Then we have this printf function %d. Then we are printing this a value. Understood? And the last one is return 0. Return 0. This was the function main. And here one more function was given with this our foo function. Foo function is given with one integer pointer parameter p, and here the other is nothing but integer x. These two parameter, fine. And here we are having only one statement here is star p is equal to x. Getting my point? This is only one statement, single statement. What is the answer for this question? What is the answer here? What is the answer? Anyone? This is basics, very simple question. So if you observe here, we are having this three variable z, a, b. So let's quickly create the memory for this a, b here, a, b, z here. Let's assume here in our main, okay. Let's see here in the main function. In the main functions, we have the three variable. We have the three variable. One is our z, one is the a, and one is the b. Okay. So this is our z. This is our a, this is our b. Let's assume the location of this a is 1000, here b is 2000, and this z is 3000. Okay. Initially this z is having this garbage value. Okay, fine. Now here see a is having this 20, a inside with this 20, b inside is 25, done. Now the second statement here we initializing this z is equal to n% of a. What is n% of a? Nothing but 1000. So 1000 will be stored inside this z here. So z will be updated by 1000. Very good. Then we call this foo function here. We call this foo function. Okay. This foo of z. What is this z? What is z? Z is nothing but here see. So what is z? Z means, okay, what is the stored value? Stored value is 1000 only. So 1000 comma b. What is b value? B value 25. So we are passing this 1025 here. We are calling this foo function. If you call this foo functions in the function foo, we are having two variable. One is p and one is x. P and x. So p will having this value 1000 and x will store the value 25. Getting my point? And location, maybe this p is having 4000 location. This is 5000 location. Okay, the statement is here. This statement is having star p is equal to x. Getting my point? What is this x here? This is assignment operator. Assignment means first right hand side value. So r value. So what is r value? This is a variable. What is value? So x value is 25. So 25. Now 25 updated to which location? C. So what is p? P is having 1000. What is 1000? Fine. So what is star 1000? Value at 1000. What is value at 1000? Nothing but here is 20. So this 20 will be replaced by 25. This is 25. Why? Because we are calling this location A with the call by reference. Understood? So this 20 will be updated by 25. Now see, as soon as we will see the cross here, closing bracket, then we will move to the main function again. So now in the main function, after this foo function call, we are having this printf statement. So printf %d and a. So what is a value in the main function? We are having this 25. So 25 will be printed by this printf function. So answer is 25. Answer is 25. Understood? Getting my point now? Done. Any doubt you want to ask? Fine. Okay. Let's discuss one more questions. Programming questions. See quickly. Programming questions. Okay, this was little lengthy. Okay, see here. This was after 2 marks questions. 2 marks questions. NAT 2 marks. C programmings, and this is of 2 marks questions. NAT. Fine. The question was we are given with here. Okay, int main, and here we are given with one printf function, printf %d, and we are calling this function call get with the value 14362, 14362. Getting my point now? Then here we are returning this 0, return this 0, and we'll closing this main function. Fine. Now see this function here. If you see here, the get function, this get function is having this return type is int get, and we are passing this parameter int of n, getting my point? And here the body of this int function is having this variable int equal to t, d, then t, then we have the new num, then we have this turn, getting my point? Now we have his scanf statement is new num equal to turn initialized by 0, both are initialized by 0, and then t equal to 1, here is t equal to 1. Then we are having this while loop, while n is greater than equal to t, then perform this statement here, t is equal to 10, means t multiplication equal to 10, means we need to execute this statement till this while condition is true. Done. Then after this we are having this t is division equal to 10, then we are having this while loop, again one more while loop, t greater than 0, execute this t greater than 0, and the statements are here, d is equal to n by t, then we have n equal to n modulo t, then we have t, okay, t divide equal to 10, then we are having one, okay, if condition, two if conditions we have. Let's make the space here, having two if condition. See here, so one if condition is if turn is true, then here return. If turn is true, then not return, it is nothing but here new number, new num is equal to 10 into new num plus d. Fine. And after this we are having this turn is equal to turn plus 1 modulo 2. Understood? Then after this just return the value here. So this is our while is closed here, while closed, then after this return the new num, Okay, 46, yeah, answer is 46, very good. This is little lengthy, means you need to execute, okay. Now see here, quickly see. So always see, start from the main functions here, inside the main we have this printf functions, and in the printf functions we are calling this functions get. So whatever the value returned by this get function, that value will be printed here. Fine, done. So we are calling this get functions with n equal to, so we are passing this value here 14,362 here. Now this value will be stored inside this get n. Getting my point here? So in the get functions, okay, a variable n will be created, okay, n, and in that this value will be stored here 14,362. Done. Then we are having many more variables here, like here I am just creating this, one is d, one is our d, here one is our t, then one is our new num, and one is our turn. Fine, here is our new num, this is our turn. Fine. Initially see here, new num and turn initialized to 0, this is our 0 and this is also 0. Then t is equal to 1, this value is 1. This value is 1, anything else, and d is having garbage value, this is having garbage value, some garbage value. Now start executing, see here. Now see here, so now the while condition, n is greater than equal to t, see, is it true or false? See here, so n value is 14,362 and this value is more than this here, means here we are having this while condition, and the n value is 14,362 greater than equal to 1, condition is true. If it is true, then simply go and perform these operations. What is this operation? See here, so t star equal to 10, anything but t equal to t into 10, okay. So statement nothing but t equal to t into 10. Understood? So what is the previous t value? It is 1 only, so this will be 1 into 10, so value is 10 and update this 10 value. Understood? So this 10 rotated by this t rotated by 10 only. Done. Now again perform the while condition, check the while condition, see condition is here. Now condition will be this value, n value greater than equal to 10, is it true or false? True. Again perform means again multiply the t value by 10 here, so now this time it will be having 100. Again check, condition again true here, true means again multiply by 10 here, 1000 only. So again it is a more value, this n is greater than 1000 only, so again multiply by 10, so this value having 10,000. still this value greater than this 10,000, again multiply 1 by this 10 here. So this will be again, and this will become again 1 lakh. Means now this value, this n value is this condition, the n value greater than or equal to this lakh is false. Now if the condition is false, then the while loop will terminate, and then we'll go and we'll execute this statement, this t divide equal to 10. So what is this statement here? Nothing but t is equal to t divided 10. So what is t value? T value is 1 lakh. So 1 lakh divided by 10 is nothing but it will become our 10,000. So again this 10,000 will be updated to this t value. So now this t value is having again 10,000. Understood? So this value is done. Now go and start this while condition. Now this while condition will be continued till the this t value is having greater than 0. Understood? Now execute this while loop. Now what is this t value? T value is 10,000. This 10,000 is here, the while condition. The while, what is this t value? T value is 10,000. So 10,000 is greater than 0. Is it true or false? It's true only. If it is true, then execute this statement here. What is this statement? Again, it is having d. Okay, d is nothing but n. What is n value? N nothing but our 4362 divide by t. What is this t? This is 10,000. This is a 10,000. So if you divide this, okay, if you divide this value with the 10,000, then what will be the quotient? Quotient will be only 1. Getting my point? Quotient means here the value, this complete value will be only 1. Getting my point? So now that 1 will be updated to this d value. Now this d is having 1. This d is having 1. Getting my point? Now again the second is our remainder. Now this n value will be updated by the remainder. Remainder is nothing but here 4362 divided by 10,000, and our remainder will be nothing but 4,362. This updated to n here. Now n will be updated to 4,362. Getting my point? Understood now? So this statement done. Now update the t value. So what is t? T is equal to t divided by 10. Understood? What is current t value? So current t is our 10,000. So 10,000 divided by 10 is again it will become 1,000. Now this t value will be, this value is 1,000 only. This value is 1,000. Understood? Again after this condition, check here, check the condition. What is the condition? If turn, what is turn? Turn is 0 only. So if the turn is 0, the condition will be false. The condition will be false. Now if the condition is false, don't update the new num. Just go and first update this here turn. What is turn? Turn equal to turn plus 1 modulo 2. So if you perform this turn, okay, turn equal to turn plus 1 modulo 2. So what is the current turn value? Turn value is 0. 0 plus 1 is 1. 1 modulo 2 is nothing but 1. Now update this turn by 1. It means here this turn value will be only 1. Done? So all is done. Now as soon as see the close bracket, then again go perform the while loop. So what is this while loop condition? Again see. So what is while loop? While is t greater than 0. What is t value? T value is 1,000 only. So condition is true. If it is true, then simply perform this d. Getting my point? So what is d value here? D equal to n by n divided by t here. So n value is nothing but here 4,062. Again see here. So here the while condition is nothing but our 1,000 greater than 0. So what is d? D will be 4,362 divided by 1,000. So quotient will be 4 only. Update this 4 to d. Now d updated to 4. Understood? What is n? N will be remainder here 4,362 divided by 1,000. So remainder will be 362. Update this to n. So n value will be 362. Getting my point? Now again this t decrement by 1, t equal to 1,000 divided by 10 means it is nothing but it is 100. Means now this t value is nothing but 100. Understood? Done. So t is updated. Now what is this if condition? If turn. What is turn? Turn is 1. It means the condition is true. This if condition is true. Now if condition is true, then update the new num. So what is this new num? So new num is equal to 10 into new num. So what is the current value of this new num? New num is 0. So 10 into 0 is 0. 0 plus d, nothing but here is 4. So 0 plus 4 is 4. Now that 4 will be updated to new num. Means it means new num is having this 4. New num is 4. Currently new num is having 4. Done now. So if condition is done, then again go and perform this turn updation. So turn is equal to turn plus 1. What is the current turn? Turn is 1 only. So 1 plus 1 is 2. 2 modulo 2 is 0. Now this turn becomes 0. This turn becomes 0. Understood? Getting my point? Now again perform the while conditions. So what is while condition? So while is nothing but while 100 now. So current t value is 100. T 100 is greater than 0. Is it true or false? It's true. If it is true, then again perform this d. So what is d? D will be our, okay, d will be nothing but n by t. D will be, okay, n by t here. So what is n? N is nothing but 362. 362 divided by 100. So the quotient will be nothing but 3. So this d updated by this 3. Understood? This d updated by 3 here. So again update this n. So n will be nothing but 362 modulo 100. So here the remainder will be, remainder here also is remainder here. Remainder will be nothing but 62. So now the n value becomes this 62. Getting my point? Again update the t by divided by 10 here. So then now this t becomes 10 only. This t becomes 10 only. Understood? Now go and check the condition here. If turn, what is turn? Turn is 0 only. So condition is false. If condition is false, don't update the new num. Go and perform the turn equal to turn plus 1 modulo 2. What is turn? Turn is 0, 0 plus 1 is 1, modulo 2 is 1. So again this turn updated to 1. Getting my point? Now again go to the while loop. Check the condition here. So what is this t? T is 10. T is 10 only. So now see here, t is 10. Let me just compress. Let me just make the space. Okay, now see what is the while condition. The while will be t. What is this t? It is 10. 10 greater than 0. Is it true or false? It's true. If it is true, then again go and perform the same here. What is d? What is d? D is equal to 62 divided by 10. So here quotient will be 6 only. Update to 6 means 6 updated to d here. So d value will be nothing but changed to 6. Understood? Now again n. N is equal to 62 divided by 10. So what is remainder? Remainder is nothing but only 2. So now the n value becomes 2. Here it is 2 only. Very good. Now here t is divided by equal to 10 here. Means t is equal to 10 by 10. 10 by 10 is nothing but 1 only. So t value is now become, this value becomes 1. This value becomes 1. T value becomes 1. Now after this again take the turn here. What is turn? Turn is nothing but 1 only. If the condition is true, then perform the update the new num here. What is new num? New num equal to 10 into new nums. What is current new num value? Is 4. So 4 into 10 is 40 and plus d. D value is 6. So this becomes 46. Here this new nums become 46. Then go and perform this updation of this turn. So turn is equal to turn plus 1 modulo 2. Again this will become 0. So this becomes 0. Turn becomes 0. Turn becomes 0. Very good. Now again perform the same here. Then see one more times here. The while. What is our t value? T value is 1. 1 greater than 0. Is it true or false? It's true. Again perform the same here. What is d? What is d? D is nothing but n. What is this n? N is nothing but 2 only. So 2 by 1. Tell me here. 2 by 1. What is d here? Quotient will be 2 here. So this will be 2. So here this d value is nothing but here 2. Done. Next is our remainder here is nothing but here see. It is nothing but 2 modulo of 1. Remainder is 0. So n value will be 0 only. So now this n becomes 0. N becomes 0. Now what is this t? This t is nothing but 1 upon 10. So here the quotients will be 0 only. So now this t value becomes 0. This value becomes 0. Understood? Now again check here the if condition. If turn. What is turn? Turn is 0. If the turn is 0, don't update the new nums. Again go perform the turn. So turn is equal to turn plus 1 modulo 2. So again this will becomes 1. Turn becomes 1. Again go to the here while condition. While t. What is t? What is this t? T value is 0. So 0 greater than 0. Condition is false. Now this while loop gets terminated. Right? My point now. So this loop will terminate, and then after this simply return the new num. Okay, return the new num. What is new num? New num is 46. 46. So what is returning here? 46. That 46 here will be printed by this printf. So here answer is 46. Getting my point? Understood? Clear? Very good. Now let's go quickly. Let's see more questions here. Okay. One more questions. Let's discuss one more questions from the operating system. Demand paging. Okay. So here this is the operating system demand paging, and this question was NAT 2 marks. NAT 2 marks. Getting my point? Here the page numbers are given in the demand paging. The page numbers are given. The page numbers was here 1, 3, 1, 3, 2, 4. 1, 3, 2, then 4, 1, 3, 2, 4, 2, 3, 1, 2, 2, 3, 1, 2, 2 3 1 2, 2 3 1 2, and then 4 3 1 4, 4 3 1 and 4. Getting my point? This was the page number. Fine, done na? And here the system is using the optimal page replacement, optimal page replacement technique. Getting my point? Optimal page replacement. The only thing is here, see, one statement was given here. The operating system correctly predict, okay, only up to next 4 page reference, okay, 4 page reference, okay, including the current one, including the current. This was the complete question, and they are given, if we are having this empty 3 frame, then find page fault, find total page fault. What was the answer for this? Anyone attended this question? How many page fault? How many page fault? Anyone? How many page fault? No idea. Okay, now see here. Now in the systems where we are given with here page number. So page numbers are given with here 1 3 2 4 2 3 1 2 4 3 1 4. Now we are given with 3 frames. This is our frame 0, frame 1. This is a frame 2. Initially all are empty. 6. Okay, we'll see here. Now see. Initially all are empty. So first page reference will always be page fault. This is a page fault here. So now insert this 1. Very good. Now again this next is also page fault. Insert this 3. Here is page fault. Insert this 2. So all these first 3 are the page fault. Done. Next is our 4 here. 4. Next is here 4. Getting my point? Now see here. This 4 is not available in this memory here, main memory. It means this 4 will also cause the page fault. Now the question is, if the system is using the optimal page replacement technique, then out of this 3, which page will be replaced by this 4? Getting my point? So as per the given statement, it says here, okay, operating system can only correctly predict, okay, only up to 4 next page reference, including the current. So current means see, we are at this 4 here. So including this current, how many page reference we need to correctly predict here? 4 only. So 4 2 3 1. This 4 page reference will be correctly predicted by the operating system in the optimal page replacement technique. Getting my point? So it means now here these 4 frames are correctly predicted here. Now out of these 2, the one will be replaced by this 4 only. This one will be replaced by this 4. Getting my point? Understood now? So now this 4 is page fault done. Now this 2 is a hit. Then here this is a hit. It is a hit. 3 is also hit. Again this 1 will cause the page fault. Here this 1 is our page fault. If 1 is page fault, again see, including 1, check the next 4 only. Check the next 4 here. So next 4 is this. Okay, 1 2 3 4. 1 2 3 4. Getting my point? So include in all this replace the 3 by 1. So replace the 3 by 1. Getting my point? Next here is 2 will be hit. This will be hit. Then 3 will cause the page fault. 3 will cause the page fault here. This will cause the page fault. Getting my point? Again, just see here, next 4, including this 3. So we don't have 4, just take the all, whatever the remaining we are having. Fine. So it means now this 4 will be replaced. 4 will be replaced by this 3 here. So 4 replaced by 3. So we are having this 1 is our hit. Okay, and this 1 is our hit. Okay, 1 is our hit, and this 1 is hit. Getting my point? sorry. Okay, so here we are having C here. Fine. So we are having last is we are having only 3, 3, 1, 4. Now check here. Now check here. So in this 3, 1, 4, if you see here, okay, including this, okay. So we are having this 3. We are requesting for this 3. Now including this 3, next 4 is having only this 3, 3, 1, 4. Getting my point? Now see in the page frame, currently here see where we are having 4, 1 and 2. So simply see, because this 2 is not referenced in the future, so simply replace this 2 by 3 only. Okay, this 3. Understood? Now the next will be hit only. This 1 is hit and this 4 is also hit. So how many page faults we are having here is 1, 2, 3, 4, 5 and 6. So total page fault for this given problem is nothing but 6. Understood? Very good. Done? Okay. Now see the next one. The next one is, see, one more programming question. One more C programming question. C programming questions. This question was given here. So we are given, this was NAT 2 marks question. Again NAT 2 marks. NAT 2 marks question. Fine. Here we are given with int main. Okay, we are given with one array. Fine, int array A, and the elements of this array are 0, 1, 2, 2, 2, 3 2s, then 0, 0, 1, 1, 0, 0, then 1 and then 1. Very good. Now here we are having one more printf function here. Printf %d. We are having foo a comma 9. Fine. Then we are having return 0. Very good. Now let's quickly see the foo function properly. What is foo function? If you see the foo function, it is nothing but here int s1. Okay, parameter is array parameter. Then we are having the size, int size. Then we have if. Okay, if size is equal to 0, then return 0. Then if size is equal to 1, then return 1. Then simply we are having if s of 0 not equal to s of 1. Okay, if it is not equal to s of 1, then here we are having this return 1 plus foo of s plus 1 comma size minus 1. Fine. Next is our, if the condition is true, then return this. Else if the condition is false, then simply return here. Return here foo of s plus 1 and size minus 1. Fine. So this, after this, okay, done. This is the complete foo function. Anyone solve the question? The question was, what is the value printed by this printf? Quickly tell me. Anyone solve these questions? What was the answer? What was the answer? It's a simple, easy questions, only needs backtracking. Fine. Anyone? What is the solution? Answer. Okay, let's discuss. Fine. Now see, first start with the main functions. In the main we have array here. Fine. We have array 0, 1. Very good. Let's quickly draw the array. Draw the array here. fine. How many elements we are having here? See, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements, fine. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Fine, very good. So here this is our array A, fine. And indexes are here. Indexes are, we can say 0, 1, 2, 3, 4, 5, 6, 7 and 8. Size is 9. Array size is 9 only. Means here the size value, okay. Whatever we are passing this 9 is nothing but the size of the array A. Fine, done. And address you can see here, anything you can keep anything here, 1000. Then here 1002. 1004, like this, 2 byte space, fine. And the values are here 0, then 1, then 2, 2, 2, then we have the 0, 0, and then 1 and 1. Very good. Done. Now again see, so int array, this array is created. Now go and perform this function call. So function call is foo. Here we are passing this foo of A. What is this A? A is the array name. So what this array name contains? Array name contains the address of the first element. So address is 1000, so 1000 will be in the array name A. So what is A value? Nothing but 1000 only. 1000 comma 9 will be passed to the foo function here, foo functions. Getting my point? Now where this 1000 will be stored here? So it will be stored in the S. In the S. It means here this S variable is also, okay, this S is also pointing to the array. This S is also pointing to the array. Fine. So we are having this foo and having this 1000 comma 9. So now this S also contains this 1000. Very good. Now we have the size. So size is equal to 9. Size is updated by this 9 here. Fine. Now let's check the condition here. If size is equal to 0, true or false? Both conditions are false here. Size is not 0, size is not 1. Then check here. See. Then check here if, what is the condition here? If S of 0. S of 0. So what is S of 0 means? S of 0 means we can say here star of S plus 0. Star of S plus 0. What is S? S is 1000. 1000 plus 0 means don't skip anything. Okay, getting my point? Understood? Or simply we can say S of 0 means the current value of this pointing, where this S is pointing, that value here. Fine, simple. Or we can say here star of 1000 plus 0. 1000 plus 0. So 1000 plus 0 is nothing but 1000 only. 1000 only. And what is star 1000 means value at 1000 here. That is our 0 value. Simple. Getting my point now? Done. Now see, S of 0 not equal to S of 1. S of 1 means this location, both the adjacent locations will be compared here. So what is S of 0? S of 0 is 0 not equal to 1. Is it true or false? It's true. Getting my point? If it's true, then simply call this return functions here, return function. Okay, return function. What is return function? It says here 1 plus foo of S plus 1. What is S plus 1? S plus 1 is nothing but, if I perform the S plus 1 means skip this element, pointing means now the S will point to this element. S will point to 1002. It means here its value is nothing but 1002, comma 1002 and comma size minus 1 is nothing but 9 only. Oh sorry, size minus 1 is nothing but here 8. Getting my point? Now what will happen? Again this function will be called here. Which function will be called here? Now see, as soon as we call the function here, again foo of 1002 comma 8. Then what will happen? Now S will point to here. S will point to 1002. It's good only. Now what is the size? What is the size? Size is 8 only. Size is 8. Again same. If size is 8, then first both if condition will be false. Then simply go and perform this if condition. What is if? It's having if S of 0 not equal to S of 1. Getting my point? What is S of 0? S of 0 means same here, same. What is the current value at that where this S is pointing? So S is pointing to 1002. So what is value at 1002? That is 1 only. Getting my point here? So there is nothing but here is 1. 1 is not equal to the adjacent is 2 only. Getting my point? Means S of 1 means nothing but here star of S plus 1. Star of S plus 1. What is S? S is 1002. So 1002 plus 1 is 1002 plus 1 means, so pointing to next location is 1004 only. So 1000 is nothing but here 1002 plus 1 means skip one element. So it will be nothing equivalent to star of 1004. So what is star 1004? Value 1004 nothing but 2 only. So this S of 1 is equivalent to 1004 only. Fine. What is value 1004? So value is nothing but 2. So 1 is not equal to 2. Is it true or false? It's true only. If condition is true, then simply return the value here. Return the value 1 plus foo of S plus 1 S plus 4 anything but here 1004 here. So 1004 comma 7. Understood? Again we'll call here foo. Again we'll call the foo. So foo of 1004, comma 7. Again, now this S will point to this 1004. S will point to this location. Getting my point? Same. So what will happen here? Now see here. S is pointing 1004. What is the size? What is the size? Size is 7. Both condition is false here. Then again check. What is S of 0? What is S of 0? S of 0 is 2. And what is S of 1? S of 1 is also 2. So this condition S of 0 not equal to S of 1. This condition is false. Both are equal only. So 1002 and 1006 both having value same value, same index value. Fine, and here done na? Both having same value here, 2 and 2. So both are equal. So if both are equal, then simply condition will be false. If condition is false, don't return this here, return this value here. Fine. So here now it will return here. It will return the value. Return the value foo. Return the value foo. Okay, S plus 1. S plus 1 means 1006. 1006, comma 6. Getting my point? Understood? So I can see 1006 we called here. Then again S will point to 1006. Now this 2 only. Now what is the size? What is the size? Size is 6. Getting my point? Now size is 6 means both condition is false. Both condition is false. Then I can check here this condition. What is S of 0? S of 0 means 1006. That is 2. What is S of 1? That is next location value. Here is 2. So both having same value. Means condition is false. If condition is false, then return this value. Return this value. Getting my point here? So again, if the condition is false here, if the condition is false, then simply return. Return the value. Return the value foo of 1008, comma 5. 1008, comma 5. Now this S will pointing to this location. Getting my point? Now simply here, what is 1008 here? Same here. 1008 means S is point 1008. What is the size? Size is 5 only. So again the size is not 0 or 1. Then again go next here. What is S of 0? S of 0 is 2. What is S of 1? S of 1 is 0. So 2 and 0 both are not equal. If both are not equal, if it is true, then return this. Again it means here. What is 1000? What is foo? What is foo? 1008, comma 5. So it will return the value 1 plus foo of S plus 1. S plus 1 is nothing but 1010. Okay, 1010, comma 4. Getting my point? Understood? Again call this foo of 1010, comma 4. This location. Now this S will point to this location. Again if you check here 1010 is having 0. Means now here the size is 4. Condition is false here. Now where the S is pointing? The S is pointing to 1010. That is having 10. 10 value is nothing but 0 only. Okay. The value at the 1000 location is 1010, nothing but here 0 only. Getting my point? So what is S of 0? So the S is pointing to this location. What is S of 0? S of 0 is 0, not equal to S of 1. What is S of 1? S of 1 is again 0. So both having value same value. If it is same, then don't return this. Condition is false means don't execute this part here. Execute this return value here. Fine. So again here it will return the value foo of okay 1012. Okay, and 3. 1012 and 3. Very good. Okay, let me just compress. Now see, almost done. Almost done here. See here. See. Then again we'll call this 1012, comma 3. 1012, comma 3. See here. Foo of 1012, comma 3. What is the size? Where S is pointing? Now S is pointing to this location, 1012. Okay, what is the size? Size is 3 only. Size is 3. Again it is not 0 or 1. Then simply go and check here. What is S of 0? S of 0 is 0. What is S of 1? S of 1 is 1. Condition is true. Condition is true, then return this value. Understood? Condition is true, then return the value. Return the value 1 plus foo of S plus 1. What is S plus 1? 1014, comma 2. Getting my point? Now S will point to this location. S will point to this location. Getting my point? Now simply it's almost done here. So foo of 1014, comma 2. Okay. Again see what is 1014. See here size is 2. It's not 0. So both condition false. Then check here. What is S of 0? What is S of 0? S of 0 is 1 and S of 1 is only 1. So both are same. Both are same means if condition is false. If condition is false, then execute this part here. Then here return the value foo and what is S plus 1? S plus 1 thing, but here this location here S. Okay, it means here 1016, comma 1. Getting my point? Now for this 1016, this value is having size is equal to 1. If the size is equal to 1, then simply see here, if the size is equal to 1, means when we pass this function call, size is equal to 1, then simply return the value 1. It means here this function return the value 1. Getting my point? And then this one value, from where we called here, we call this function 1014, 2 here. So value of this 1014, 2, this value is nothing but 1 only, 1. Okay. Now see here, so this function 1014, 2 is called from this 1012, 3. So what is the value of this 1003 here? This value is 1 plus 1 is 2 only. This value is 2. So from where it was called? It was called from this location here, 1010, 4 here. So value is nothing but here, this value is nothing but here 2. So value of this 1004, this also having true only. Similarly, what is the value of 1010, 4 here? This value 1010, 4 nothing but here 2 only. Okay. Now see, so from where it is called? It was called from 1008, 5. So what is that 1008, 5 here? So 1 plus 2 is nothing but 3 only. Getting my point? Now see, from where this was called? This was called inside here, see. This was called from here. So this value is nothing but this value, nothing but here it is 3 here. So from where it was called? It was called from 1006, 6. So value of this nothing but here is 3. So from again where it was called? It was called from 1004, 7. So value of this is 3 only. So again, what is value of 1004, 7 is nothing but 3. So from where it was called? It was called from 1002, 8. So what is value of 1002, 8? The value is nothing but 1 plus 3 is nothing but 4. So from where it was called? It was called from this here, 1002, 8. So value is nothing but here 4. So 4 plus 1 is 5. So from where it was called? It was called from 1000, 9. So value of 1000, 9 is nothing but 4 plus 1 is 5. So it means here the value written by this foo of 1, 9 is nothing but is 5. So answer is 5 only. Getting my point? Understood? So if means no need to execute this much here. Means after having 2, 3 statement, so you can clearly see here, means it is comparing adjacent 2 value, and whenever it is both are different, if both are not equal, then it will call plus 1 plus foo. It will call with 1 plus foo function. Getting my point? It means here, so here not equal is how many times are not equal? See, we are having this is not equal, then again see this is not equal, then again both are equal, this is not equal, then again see here, again see it's a 0, 0 is equal, then again see this is not equal. Getting my point? Done. So again, how many here? How many times here? See, 1, 2, 3, and 4. And again, 4 times function will be called, and plus 1 for the original function. So simply it will answer will be 5 only. Okay. Done now? Fine. Now, any more questions here? Let's see some questions here. Now see here, see one more questions from this algorithm. It is of 2 marks questions, 2 marks NAT 2 marks question. Okay, the question was the maximum value of x, such that as between B and C is included in every MST, minimum spanning tree, of given graph G. Fine. And the graph was given here. The graph was given A, B, D, and C. The graph was given here, and the value was 6, it was 7, it was 8, here it was 3, here it was 1, and this was x. So find the maximum value of x. What is the maximum value of x? Such that this x must be included in every MST of this given graph. Getting my point now? Simply apply the Dijkstra method. Find the cycle. See here. See, start with the MST creation here. See here. So we'll be having this A, B, C, and D. Fine. Now see, asking for the maximum value, see, definitely I can say here, this edge from B to D will be in the every MST. Why? It is having minimum value, okay? So this is B and D will be in the every MST. Getting my point? After this minimum is 3 only. So choose this 3 here, see, B and C is 3. Getting my point? Now see here, after choosing this 3, we are having this 2 component, but this is a disconnected here. Fine, one component is our B to D and one is our A to C. We need to connect this both components. Getting my point? So one option here, how many options we are having? I have options, either I can connect here AB, or I can join with the BC, or I can join with the here AD, or I can join with the DC here, fine. But it is asking what is the maximum possible value of this X here. Getting my point? Now see here, can I keep here? Can I keep maximum value is 4? Yes, possible. If you keep this 4, again BC will be in the every MST. But asking for maximum, see here, can I keep this as a 5? Again, it's possible here, 5. Why? See here, again if I keep the value of 5 here, so again see after 3, the next minimum will be 5 only, and that X will be always in the MST here, B and C as. So now see, notice here, now can I keep this 6? Can I keep this 6 here? Tell me, can I keep this 6 here? If you keep this 6 here, X equal to 6, then what will happen here? Some MST, so some MST we can pick here this 6, A to D. In some MST I can pick this as here, A to D is 6 only. And in some MST I can pick this 6 here. If I keep this X equal to 6 here. Getting my point? It means if you keep this X equal to 6, then in some MST X can be present, but it will not present in every MST. But as per the question, this says here, this B and C A's must present in every MST. It means the maximum possible value is nothing but here, it's possible is 5 only. If I keep this 5, then definitely this BC as included in every MST. Getting my point here? It means X is equal to 5. So maximum here, maximum possible X value is nothing but here 5. Understood? Done na? So maximum possible X value here, this is nothing but maximum X is nothing but 5 only. Okay? So this value will be 5. If it is 5, then definitely this will be included in every MST. Done? Very good. Okay, now let's discuss some, okay, I was noting this some TOC questions. See here, the TOC questions, one TOC questions I am discussing simple. This TOC questions here is MSQ 1 marks. Okay, TOC questions MSQ 1 marks. Okay, it was given with given a grammar. It was given with a grammar G. A grammar was given. S is equal to AAB. Then it was ABB, and then here expansion of this A was nothing but A and small a, and the expansion of B was nothing but B, and simply this was the given grammar. Fine. And here asking what is the language accepted by this grammar, means L of G. Need to find the L of G. So here options were here, options was given here, options was given L of G. Option A was given language of G is nothing but A to the power of 2n. Okay, A to the power of 2n, and here this B to the power of 2n, where n is greater than equal to 1. This was the first option. And the second options, B option is L of G. L of G is nothing but here, L of G nothing but A to the power of n, B to the power of 2n, n greater than equal to 1, union A to the power of 2n, B to the power of n, n greater than equal to 1. Understood? And here C, L of G. L of G is nothing but here A power of n, B power of n, n is greater than equal to 1. Understood? And this D was nothing but A to the power of 2, B to the power of n, n greater than equal to 1, union A to the power of n, B to the power of 2, n greater than equal to 1. Tell me here. Anyone solve the questions? What is the answer here? Option. What is the answer? what is the answer for this question? Tell me, anyone? Okay, now see here, now see, if you observe the grammar here quickly, you can just simply substitute, back substitute here, fine. It means we can say here, if you see this B part, B, we can simply okay, back substitute here, fine. So back substitution means here again, if I expand here B equal to BB, then again B, like this here. So minimum how many times we can get here B is nothing but minimum will be 1. Take my point, and maximum it will be any times here. So I can say here, so B is nothing but is equal to B power of n, and here n is nothing but greater than equal to 1. Similarly for the A here, similarly for the A, we can say here the expansion of this A is nothing but here I can say A is nothing but A to the power of n, and n is nothing but greater than equal to 1. Understood? Fine. Now simply if you back substitute all this value here, see here, the S is nothing but here, the S is generating two part, okay? Okay, generating two part. One is nothing but here, having this A, B, and having this A, B, B. Fine. So if you substitute this B part here, simply this B part, so what can we get here? A to the power of n, okay, this B to the power of n, okay, n is greater than equal to 1. So what language we are getting here? So language we are getting from this expansion here, nothing but A square B to the power of n greater than equal to 1. And other nothing, because of this expansion here, I can say the x is expanded to here A to the power of n, B, and n greater than equal to 1. If you see here, this expansion is nothing but A to the power of n, B square, where n greater than equal to 1. Simple, back substitution. If you see here, so using back substitution, we can say here the answer is nothing but here, answer is nothing but options D. Getting my point? Again, see here, option C, check here, option C, is it possible to get this? Okay, same number of A and B here. So if you clearly see here, so if I expand this one, okay, let's keep this n equal to 2. If you say n equal to 2, then C option will generate one language. Okay, that is nothing but here. Okay, if I keep this n equal to 2, this will be A and BB. Fine. So check here, A and BB. I can see here A and B possible here, but I can see here, some cases will be not possible. If I say here, so just check here one grammar part here. If I say here, S is generating here A, and this B nothing but A, substitute this B by B here. So this nothing but S is giving here A and B. So if I take this example here, this language, this string is generated by the grammar, but this is not accepted by this language here. Or we can say this string is not part of the C option language. It means here, this is option C nothing but incorrect here. It is C here. I can say this is a subset of this part. Okay, this language option C is nothing but is a subset of the given grammar. Okay, but this is means there are some string which is generated by the grammar, but it is not accepted by the given language here. Option C here. So option C is the incorrect here. Fine. Then same with C here. Option B also incorrect here. And same you can say option A also correct here, because we are having this minimum value is nothing but equal to 1. I can say, so here it is not generating here minimum, same here. See here, this string is not generated by here. See, this string here, sample here AAB is not generated by the option A, but is generating by the options. This given grammar is generating this string here. Understood? That's why option A is incorrect. Fine. Yeah. C is incorrect now. Just said here C. Option C is incorrect here, Baba. C. Option C. This option C, whatever the language we are having, A power of n, B power of n, this language is not generating this string AAB, but this string is generated by the given grammar. It means here some string that is generated by the given grammar is not covered by the option C language. That's why option C is incorrect. Understood? Done? सर पेज रिप्लेसमेंट वाले का आंसर 2 क्यों 4 तक? पेज रिप्लेसमेंट okay, let's see. Page replacement here. हाँ, what is the problem? 2 होगा, क्यों 4 तक कोई पेज फॉल्ट नहीं होगा? 4 तक, why we don't having any page fault till 4 here? Because see, initially all the frames were empty. Getting my point? If all the frames are empty, then definitely the first 3 page difference 1, 3 and 2, all this will be nothing but a page fault only, because that page 1, 3 and 2 are not present in the memory. Getting my point? It means here all the first here, all this first is nothing but page fault. Again same is nothing but 4. Now for see, now for this 4, second line. For the 4 reference. Yes, see, correctly predicted, but again see here, again I can say कि out of all this, see, initially the page was, this complete memory was empty, na? Initially the frames was empty. Here in the problem it was given the frames are empty. The frames are empty. If the frames is empty, then definitely the first, at least the first 3 reference will be your page fault. You need to transfer that page from the disk to main memory. It will correctly predict the first 4, but the first 3 will be your page fault. To transfer, what is page fault? What is page fault? Page fault means that page means whenever the CPU is requesting for the some data or to access the page, that page is not available in the memory. Understood? If the page is not available in the memory, then you need to transfer the page from the disk to main memory. So initially all the frames were empty. So now it's correctly predicted this, see, it's correctly predicted this 4 frames, but we need to transfer this 1, 3 and 2 from disk to main memory, and all this cause the page fault. Simple. No, answer will be 6 only. Okay? Answer will be 6. Fine. Let's discuss. Any problem here? Questions almost done. Okay. There was some questions in the linked list, na? In the programming part, there was one questions in the linked list. Okay. We are given with 2 linked list here. We are given with the 2 linked list. And it was null. Similarly, like here we are given with 2 linked list. It was null. And the question was something, here we will be having this pointer 1 pointing to the first linked list, here it is a pointer to second linked list. Fine. Means basically see, means initially in the program, in the main program, okay. So we are taking the one key from the linked list first, and that linked list value, okay, that node value is passed in a function, and that function was basically finding the key into the second linked list. If that key is present in the second linked list, then simply remove that node and link this previous node to the next node, like here. Means whatever the common value we are having, we are deleting that node particular from the linked list 1. Understood? For that part here, this linked list, the last linked list having, it was question was how many nodes, means after this complete program, how many nodes were in the linked list 1. So answer was, I think it was 5 nodes. Answer was 5 nodes. So we'll see, this was lengthy question. Okay. This was one of the questions, and one more question was from the min heap. Finding, the question was find the height of a tree with given the min heap have 32 keys. Fine. And we already know in the classroom that min heap follow the structure of almost complete binary tree. Getting my point? Understood now? Almost complete binary structure means here, what is almost complete binary tree structure? It means here, whatever the tree we are having, that tree will be filled. Okay, till second last label. Okay, second last label will be completely filled, and the last label, this last label will be filled from left to right. Getting my point? This is the structure followed by the heap. Fine. So I can see here. So I can see, so how many levels required for this 32 keys, 32 keys. Getting my point? So if you see here, the maximum number of nodes with level 5 is nothing but 2 power of L minus 1, nothing but 2 power of 5 minus 1 is 32 minus 1 is 31 keys. Means 31 keys will be the maximum number of nodes for the 5 levels. Means if the level of the tree is 5 here, means like here, if the level of tree is the 5, okay, if you increase one more level, like here this, fine. So this level, how many levels we are having? This is level 1, level 2, level 3, level 4, and the last one is level 5. So with 5 level, all levels are completely filled. Maximum means all levels are completely filled. So maximum number of nodes with the level 5 nothing but 31. But we are given with a problem that the mean is having 32 keys. So one more key is required to insert into the heap here. It means at the last level again, the last level insertion always done from left to right. So that 32th key will be inserted from this left right here. This is nothing but our 32th keys. Getting my point? Done. So it will increase the height by 1. So how many level we are having? 6 level. So again, what is the relation between height and level? So height is nothing but is level minus 1. So what is the level with 32 keys? Level is 6 only. So height will be nothing but 6 minus 1 is nothing but 5. Getting my point? So height will be 5. So height of the tree will be nothing but it will be 5 only. Answer was 5. Done. So this was the almost questions I have remembered, and some questions. Okay. So now we'll discuss this. JP sir will discuss this digital logic. Okay. All the best. Bye bye. Take care.
Hello students, all of you can share your experience regarding CS forenoon session paper. How was the paper? Yeah, many of you might be saying that moderate, right? Yeah. So till now, I hope all of you got to know like whatever the memory based questions our faculties have discussed, right? You people have cross verified whether your answer is correct or not, like that. Okay. Now I am going to discuss one memory based question regarding computer network subject. Okay. So this is the question is of NAT type and the question weightage is 2 marks. This question is of NAT type and it is a 2-mark question. If 5 bits are transmitted, and the probability of flipping the bit the probability of the flipping the bit is 0.01. Comma, then the probability of the received message is error free. Will be dash. So how many of you solved this party question? All of you can mention the chart. Yeah, in this question, this is the NAT type of question. Answer you will be getting a number, and here in this question it is mentioned that note point, whatever the answer you are getting, you have to round off to the 3 decimal places. Accuracy up to 3 decimal places. So this is the question given. See, you can solve this party question in 2 methods. Okay, I will be discussing in both the methods. So just observe here. In this party question, it is mentioned that you are having total number of bits transmitted is 5. Okay, and the probability of flipping the bit. That means whatever the bit that you have transmitted, at the receiver you are getting ulta. Suppose if you have transmitted 0, you are getting 1, or if you have transmitted 1, you are getting 0. So that means error is there. Okay, so the probability of the one particular bit you are getting the error at the receiver, the probability they have mentioned 0.01. Okay, just for reference, whatever the data they have given, I am writing here. So number of bits given is 5. The probability for getting error in one bit they have given as 0.01. Okay. Now with this understanding, tell me what will be the probability for getting the bit at the receiver as correct. See, whatever the bit from the transmitter, it has been transmitted at the receiver. Suppose if bit value 0 is transmitted, you are receiving 0, or if bit value 1 transmitted, you might be receiving 1. If you are getting like that, that means there is no error. Instead of that, if you are getting ulta, you are getting error. In that particular bit, error is there. So that means only 2 possibilities are there. Whatever the bit that you are receiving, either you can get as the correct or you can get as the error. Correct? So that means sum of all the probabilities equal to 1. So with the help of that, so probability of getting bit as correct is nothing but 1 minus probability of getting the bit in error. Correct? So 1 minus PE, from here you are getting 1 minus 0.01. So that is nothing but 0.99. Okay, right. Yeah, now let us read the question further. Here the question they are asking is the probability of the received message is error free. So error free means whatever the 5 bits that you have transmitted at the receiver, you should get exactly same. That means there is no single bit in error. Okay. So whenever you're having a question like this, I hope all of you are having the idea that by using the binomial formula, like NCR into P power R Q power N minus R. NCR P power R Q power N minus R. Okay. So here the context is what? Here the context is probability of getting error. Okay, whatever here we are having, that one you can label as P according to this particular formula. Probability of getting error is P. And that means here probability of getting the bit which is no error, or in other words you can say the bit that you have received as correct, so that is nothing but Q. That is nothing but Q. Okay, and in this case number of bits are 5. Okay, now here in this question they are asking that the probability of whatever the 5 bits you have transmitted at the receiver, you should get error free. That means all the bits are correct only. All the bits are correct only. Right, now with this understanding here, so all the bits correct means there is no single bit in errors. Very, yes or no? If all the bits you are getting at the receiver as correct, that means there is no single bit in error. So that means here R value is going to be 0. That is the most interesting thing. Okay. Now here P value is 0.01, 0.01 whole power, R is nothing but 0. R is nothing but 0. And then Q value is 0.99 whole power N minus R, that is nothing but 5 minus 0. So I hope all of you know this value 5C0 or NC0 is nothing but 1, and then 0.01 whole power 0 is nothing but 1. So you are getting 0.99 whole power 5, correct? 0.99 whole power 5. So this value can do the simplification. You will be getting 0.95 0.99. In the question they asked that you can round off to the 3 decimal places. So accordingly when you are rounding off, you will be getting 0.95. So here 3 digits we have to consider. After the third digit, whatever the value, decimal value you are having, if that value is greater than or equal to 5, you can add 1 to the previous. Okay, since 9 is greater than 5, so you can add 1 to the previous. So accordingly you are getting 0.951. 0.951 you are getting. So this is one method. Okay, now I am discussing one more method. See, this is a very important model. You can solve with the help of probability concept, or according to the context of the question, this question belongs to computer networks. But with respect to the terminology wise, if you understand the question meaning and logic, then you can solve even with the help of probability concept, because this kind of formula you might have learned, correct, regarding the probability. Fine. Now I am discussing method 2. See, whatever the 5 bits you have transmitted, okay, you are receiving all those bits independently. So in the question they clearly mentioned that whatever the 5 bits that you have received, okay, all the bits should be error free. So that means each and every bit, in order to get as the correct, that is independent events. So when you are having number of events are independent, if you want to find out the corresponding probability, is nothing but in like for each event, whatever the probabilities you are having, you can multiply, correct? You can multiply. Yeah, if you mention 0.950, that also they may consider, because for NAT question definitely they will be given range of values. Okay, since in the question clearly mentioned that you have to round off to the 3 decimal places, so it is the most important. After the third digit, if the digit value is greater than or equal to 5, you can add 1 previous to the, okay. So in the answer key, when they are in the gate committee they are releasing, if they mention range of values, okay, so in that range of values, if your answer fall, definitely you will be getting the marks. Okay, because 0.950, 0.951, almost closer only. But accurate wise, this one is correct, but generally for NAT question, they are providing the range of values. Accordingly, you can cross check after they have released the answer key. Okay, right. So now in this case, in order to get each and every bit as correct, the probability is this one, 0.99, 0.99. So like that, every bit you are getting correctly. So like that, 0.99, 0.99, like that you have to consider 5 times. Okay. So for the time being, I'm just, instead of writing that much number many times, I'm just putting in simple words like PC, I'm multiplying with 5 times. Okay, now this one we can write as PC power 5, whereas PC is nothing but 0.99. Yes, once again same answer. See, this is one approach, this is another approach. Actually, whatever this particular approach is there, okay, now with the help of this approach, whatever the expression you got, that expression you can compare here. Yes, this entire value is 1. Now you got that 0.99 is nothing but PC whole power 5, exactly same. So these are the two approaches. With any of the approach, you will be getting finally same answer. Finally same answer. So directly I am writing the approximated value 0.951. 0.951. Okay, right. So I hope all of you felt, whoever attempted this particular paper in the forenoon session, I hope many of you felt that the paper was moderate. Okay, right. So till now, whatever the memory based questions we have received, our faculties have discussed regarding the computer science forenoon session. Okay, so in the evening we are having at 6:30, we are going to start regarding computer science afternoon session, live exam analysis. Okay, right. So all of you stay tuned. We'll meet you all in that session. Thank you everyone.